what's going on with you guys over there? How's production going? Are there any updates since we last spoke?
Oh, right. Well, we've completed our factory, the phase one of our AMP factory in Casa Grande, and we're actually building our pre-production cars off the line there. And I had the pleasure of drawing one of our very latest ones just last week in a video we put out yesterday. And each one is getting progressively better. We're going to build probably about 120 of those before we actually get to start a production proper. And we just got to dial in this and get the quality right.
Excellent. Yeah, I remember that you guys had a tentative spring date for the release. So is there any update on that? Has that changed at all?
Yeah, it has. We were pushing for spring, and you know, I was pushing like crazy to get it ready for start of production for spring. And then when we went through the SPAC process with Churchill Capital, and I spoke with Michael Klein and his key advisor, his technical advisor, Alan Mullally of Ford and fame, we really had a meeting of minds. And they said, look, Peter, why are you pushing like crazy for spring? We need to get the quality right, whatever happens. And so they took that burden off me. They entrusted me to just prioritize the quality rather than the artificiality of a deadline, you know, the end of the spring, June 21st. And so we decided that since we were going to go public through that merger process, that we'd better under-promise and over-deliver as a public company. So conservatively, we said, look, second half of 21 for start of production. And we put that in all the merger documentation from the outset. So, you know, as a merged company with our manifesto for merger, that was clearly there from the start, second half of 21. And that means that I can focus on getting the quality right. And because this is a one-shot deal, you know, if you look at when Tesla launched Model S back 10 years ago, everyone was so blown away by electric performance. They kind of forgave the quality issues. They were kind of lost in the weeds because the car was so fantastic. I think that we will not be cut that level of slack, quite frankly. I think we've got a much more mature market now. The customers are going to be that much more discerning, and we just have to get the quality right. Now, this is against the backdrop of launching a new product, a new company, first product, again, with a world pandemic. And that has affected so many of our suppliers, and that's impacted upon their ability to provide quality parts on time. And that's been the main reason for this, this change of timing to go into second half of the year. We've got about 3,000 parts coming in from roughly 250 suppliers from right around the world. And some of those are doing a fantastic job. And others, it's very challenging because normally we'd have our SQA teams visiting those suppliers at their plants, the supplier quality audit teams. Those are employees of Lucid who would go and check that those suppliers are on track, on time, and making the parts to acceptable quality. And that's normal. Our SQA teams will be flying around the world, visiting plants on all continents, and with a finger on the pulse as we get this point of convergence at start of production. And of course, they haven't been able to do that because of COVID. Not in all cases, but in many. And so coordinating all that convergence of great quality parts from a worldwide supply base has been an extraordinary challenge because of the pandemic. It's always difficult at the best of times. And particularly since we're aiming for such a high benchmark, a high bar in terms of the quality. And then, of course, we're doing the final tests on the actual product. We have to get the car EPA range certified with the Environmental Protection Agency. And so that's one activity stream. Another one, of course, before we can legally sell the car, we have to do all our crash test program through the FMVSS, the Federal Vehicle Motor Safety Standards. Although we've done a lot of crash testing very successfully with our prototype data fleet, none of that counts because you have to, in order to homologate a car, that's to make it legally able to sell in the US, you actually have to crash test actual production process representative cars. So it doesn't count because the prototypes aren't to production process. You effectively have to make those cars on your production line with production representative parts and production representative process. And you only get to that stage by its very nature just before you're ready to go into production. So it's always this sort of unnerving moment. I mean, as I've been a chief engineer for many, many years, it's always the litmus test for a chief engineer is crash test, and it's always, for any program, really close to when you start production. So, you know, the buck really stops there.
Cool. So one of the most common complaints in my video was that people love the car so much, but they just wish they could afford it. So I was wondering if you could speak more to your methodology and strategy behind launching an expensive car first, and then kind of taking the lessons learned and working your way down eventually to an affordable mass market electric vehicle, which seems to be the strategy that some of the other electric automakers have chosen in the early stages as well. But I'd like for you to expand on that if possible.
That's a great point, because, you know, I really empathize. I read all these comments and they say, oh, another electric car that's really expensive, a rich man's toys. What the world needs is a $30,000 car for the man in the street. And I couldn't agree more. And then you think, well, why am I doing this? And so this is so misunderstood. There's a great paradox. Almost the more expensive the car, the less it costs to design, develop, and put in production. Now, let's look at two extremes. Take a Rolls-Royce versus, say, a Volkswagen Golf. Now, the Rolls-Royce is made in tiny numbers, largely hand-built in quite a small plant. And the tools to make it, because you're not making so many, they don't have to be such high-quality, high-investment tooling. So actually, putting a new Rolls-Royce into production doesn't take that much money in relative terms. On the other hand, if you look at the Volkswagen Golf, that's a product that needs to be literally made by the millions. So it needs a massive factory, high degree of automation, and it becomes a numbers game, high numbers, low margin. That costs tens of billions to do that project. So you've got this great paradox that you'd think, well, the expensive car, the expensive car is actually less capital intensive than the less expensive car. And that's why Tesla started with Model S and moved to Model 3. And it's only now they're in a position where they've got sufficient wherewithal, they've got sufficient financial muscle and maturity as an organization that they can contemplate doing this sort of mythical $25,000 car. But there's another reason. So, I mean, you could say, well, first of all, if I try to make the car I want to make is the $25,000 car, really. But if I'd gone to the market and said, look, we're a new company, Lucid, and we've got 50 people, and can you give us $25 billion so we can make a $25,000 car? We'd have just gone bankrupt. No one would be interested. But to do a high-end car, it requires less capital to start with. And we've been able to do that. We've been able to secure that capital with great partners, and we've been able to survive. So we will progressively move to more affordable cars. We'll take Air from 161,500 with Dream Edition after the federal tax incentive. We're going to take that down under $70,000 to Air Pure by next year, in 2022. We're going to bring out Gravity, but then my passion is to do our second platform mid-decade. That will be our sort of $45,000 car. And then after that, you could say, well, it's going to take what, 7 or 8 years before Lucid's big enough and has access to sufficient finances to do a $25,000 car, which would be my dream. And I think, well, I'm really good about the environment and global warming, and the world can't wait 8, 9, 10 years for Lucid to get big enough to do that. We need millions of electric cars fast. And all those comments that people say, we need affordable cars, I totally get it, and I totally agree with them. It's not me going on an ego trip to make the world's best car. That will define the brand. The first product defines the brand. So how could we sort of square this circle? And I think there is a way. I think that if we could make our technology licensed to other automakers, to traditional OEMs, maybe it's them that make the $25,000 car. Because surprisingly, it may surprise you, and I won't surprise you, Evan, because you've seen the technology that we've got. That although we're using it in a high-end car, we've paid so much attention to mass producing that electric technology, the battery pack, the motor, the inverter, transmission, that entire system, and the Wonderbox, that we've made it so that it's truly mass manufacturable, much more than anything else in the marketplace today. And that would surprise some people. That is our mission. Our mission is to truly mass industrialize electric cars and electric powertrain systems.
So, for the time being, a lot of people seem to enjoy driving their cars, but a lot of people argue that the general trend 10, 20 years down the line seems to be heading for fully autonomous transportation as the safer alternative, and just the way that makes the most sense for people to get around when we're living in the future. So how does Lucid think about fully autonomous driving, and how is your system now designed to eventually play into that?
Right. Well, we've got we're launching the Dream Edition with Dream Drive, Lucid Dream Drive, and we've taken the approach that we need to be world class in terms of the hardware suite for it. I'll go into the software in a moment. So we've got, for Dream Drive, we've got integrated 32 sensor suite, 14 cameras, including driver monitor. We've got surround near range radar. We've got a long range radar in the nose, and we've also got 120-degree solid state LiDAR in the nose, and that's good for about 140 meters. So we've got a super comprehensive sensing suite. We've got 2 terabytes of onboard storage, a massive computing power, and we link a lot of this with our Ethernet ring, our gigabit highway in the car, a nodal ring, which is revolutionary, and the car's super connected as well. So we've got the ability to get big data to and from the car, and really the ultimate in sensing. But let me tell you, the enormity of the challenge to solve, say, a level 4 autonomous software. Anecdotally, the general consensus in Silicon Valley, where I am here today, is that is a $10 billion and 10-year problem. And I was talking to a renowned executive just the other weekend, and he said, no, PD, you've got it wrong. It's a lot more than $10 billion. Nobody really knows. Now, this was really hot stuff a few years ago. Everybody was predicting fleets of robo-taxis by 2018, 2019 latest. And I was quite bearish about it. And I am bullish about really taking electric cars to another level. I don't think they've been optimized at all yet. I think there's a lot more mileage in electric car technology. But I'm quite reserved about my view about when we get to level 4 autonomous. I think it's a considerable intellectual problem. And don't get me wrong, I think it's a matter of when it happens, not if. So, we don't have access at Lucid to spend $10 billion on software. So I've taken the approach pragmatically of being competitive. We'll go to market with a level 2, maybe a level 2 plus level of autonomous driving. And we can over the air upgrade that car with a sensor suite is good for level 3. We know that. But pragmatically, do I then spend billions on developing in-house AD software when, you know, that we need every penny to get, you know, a range of products out now? I know, I think the pragmatic route would potentially be to partner with someone else in Silicon Valley on the software side. And that's the pragmatist in me.
Do you guys have any plans for providing that technology for other car manufacturers, or are you guys keeping all the juice to yourself?
No, I'd love to. That's the vision. That you know, what we're going to do is going to be huge. I mean, people think we're just going to be this niche player just doing luxury electric cars. That's how Tesla started. Tesla just was a niche player doing Model S, and it grew into this mighty oak from this little acorn. And we're really like where Tesla was 10 years ago. First product high-end car, but already we've got energy storage. First prototype ESS system here in the building. We've got a solar farm fitted out on the roof now. That's nearly complete, and we're going to hook that up later this month. We're going to get a beta prototype rolled out. I want to put that in the factory in Arizona, and I want to start industrializing commercial energy storage systems, battery electric, next year. So that's going to be one division. So there's going to be Lucid Cars, energy storage systems, and then Lucid Technologies. Now, a great example of Lucid Technologies is what we're doing with the World Championship Electric Racing Series, supplying the battery. You saw that during the course of your visit, and that's been very successful. And although a tiny revenue stream for us, but in terms of learning, it's been invaluable. I'd love to supply our technology to a whole range of other car companies, to other industries, to agriculture, to mining. I think there's going to be an explosion of eVTOL aircraft over the next decade. And don't worry, I'm not planning to go into the aircraft business, but they all need a really, you know, gravimetrically energy and power dense integrated powertrain, electric powertrain system. And that's exactly what we've got. Our technology ideally lends itself to. Now, regarding that transfer to other car companies, the drive unit that you saw is rated up to 670 horsepower. I don't think a Honda Civic or a Volkswagen Golf needs 670 horsepower. So we would have to develop a scaled down version of that. But you saw how compact the version at 670 horsepower is. You can literally put it into a flight bag at 74 kilos. Imagine if we did a version which was like 200 horsepower. It could potentially be literally the size of a shoebox. And, you know, think of that, what that would do, how it could transform a small family car, because it would actually have, offer less incompressible distance at the front of the car. So it would free up more crumple space, and it would actually make the car safer. So that miniaturization, not only would it make more legroom and more practicality in that smaller car, it would actually save lives as well. And that is the prize that we have at our fingertips here.
Do you anticipate that there's any possibility that becoming a supplier could eventually become the majority of Lucid's business over being a car manufacturer?
Could be, it could be. I mean, there's three divisions we're going to have: our cars, energy, and technologies and suppliers. And we're already talking to a well-known established car company now regarding the supply. And I've actually had a number of inquiries just this year. And right now it's difficult to do that because I'm so focused, laser focused on getting the Lucid Air into production. And that is, you know, 99% of our focus is on that right now. So But it's nice that that companies are already approaching us. I'm not reaching out to them.
So with the Lucid Air as the primary focus, I'm wondering where Project Gravity, the SUV, is. Is that project on hold when you're making such a strong push for the Lucid Air, or is there ongoing development on the SUV as well, happening simultaneously?
Yeah, I think it's about 1 or 2% of our efforts is pushing Gravity along. And that sounds small, but we've got 2,000 people now. So you can have the advanced engineering team, the advanced studio team. Most of the studio, Derek Jenkins' studio, is working on Gravity right now. There's a tiny amount of work, finishing touches on Lucid Air, but the bulk of studio work is in Gravity. I had a great design review just this week at the back of the studio to review the latest design themes. It's making great progress, and we've got a small team of advanced engineering engineers working on Gravity. This is normal, you know, when you start a program and you do the advanced engineering phase, it's just to lay out the car and establish the key parameters, where people sit, where the line of sight are, the legal visions, what we call the H points, the heel points, the H30 dimension, which is the height of the heel point, the point rather above the heel point, and the seating layout and the overall proportions of the car. You know, you can do a lot with about, you know, just 5 or 6 engineers. 10 is it can really hit that quite hard. So we're at that stage in advanced engineering of Gravity.
So you know I've been bugging you about this, but my most important question is, when can I drive one?
Well, I would love you to drive one, but there are issues. I'm allowed to drive it because I'm an approved test driver. So legally I can, because we have certain suppliers doing anti-lock braking systems tuning, traction control system. And legally, we can't give this to people outside of the company to test drive. Unless there's an exceptional circumstance, and an exceptional circumstance is where Alan Mullally actually drove the car, and we made provision for that. But if you look at the industry standard, when did a journalist first drive a Ford Mach-E? Well, that was very close to when it was started production. If you look at when Model S was launched, journalists didn't drive Model S 3-4 months before start of production. It was only when it was in production that journalists drove the car. And the same is true with Model 3 and every other car company in the world, because we have to get it right for our customers. And we don't want journalists to be underwhelmed with anything other than the final product, which is good enough for our customers. So you actually get this convergence point that it's good enough for the customers at SOP, and at the same time, it's good enough to hand to a journalist. So I would love to, but we can do rides in the car, and I very much welcome you to take you for a ride in the car.
So, I mean, how do you think about how some of the innovations you guys have made on Lucid could translate over to electric aircraft? Do you have any ideas on that, just off the cuff?
Well, I mean, I'm seeing incredible opportunity there, because, you know, in the eVTOL space, and there are so many opportunities with electric motors, because you can run multi-propeller systems. You can have miniature motors. You know, you've seen a lot of these designs having like 14, 15 propellers. And you could never do that with internal combustion. You could not really do that with jets, but you can do that with micro motors, distributed. And that gives, I mean, you can start playing with coanda effects, inducing coandas, you know, and all these advanced aerodynamic techniques through ducted multi-fan solutions. So, you know, I think there's a world of opportunity there, but what they all want is gravimetric energy density and gravimetric power density, and that's what we've got.
That's kind of what I discovered in doing my research, and that all these separate teams all over the world working independently. There's kind of some convergent evolution that they all arrived on distributed electric propulsion, multiple motors being the key solution.
And I think because our technology is scalable, they're not going to use a single 670 horsepower version of our motor. What we need to do is make 67 horsepower, well, 60 horsepower versions of it that are this size, you know, and have that distributed and a distributed propulsion architecture. Now, what I think where we could be a real gift to that whole revolution is that heaven knows it's challenging enough for a small company to start up and create an electric aircraft. But if they're trying to solve the electric powertrain as well as doing that aircraft, I mean, that really multiplies the challenge and it multiplies the risk of failure. And it's interesting, you know, with jet engines, there were, you know, the Rolls-Royce Aero engines and Pratt and Whitney that became a standard jet solution. You know, Boeing would buy in the jet. Could we become the Rolls-Royce Aero engines of eVTOL? There's a mouth-watering prospect. We're many steps away from that, but I can see the opportunity.